Okay, so in a previous video, we were talking about how there's this cardinal rule for functions, which says for each input value, we talked about buttons on a vending machine. For each input value, there can only be one expected output value. And every time you push this button or every time you plug this input in, you should get this item or this output every single time. We talked about what that looks like in terms of the graphs, how when you have a point, and we can even do, one that we didn't talk about, like -1, when I put -1 here into this function, let's say I want to make -1 the input, that would mean, and we'll talk about this in another video, I'm putting a -1 in for x. So this becomes 4 times -1 plus 8. The input of -1 produces an output of 4. If I put -1 here, the output, +4, the output's going to be +4 every time, right? I'm not going to plug -1 in and have another point down here and then have another point here that I could get two different outputs. It's always going to be the one output. And the most succinct way to explain that is with what we call the vertical line test. Okay, vertical, straight up and down. The vertical line test takes any function, and when you look at its graph, right, this is a test for the graph. Keep that in mind. Okay, when you look at this graph, if I draw a vertical line anywhere on here, that vertical line is going to hit this graph in one place. There isn't a single line that I could draw. Sorry, that one didn't go quite straight. You get the idea. There isn't a single line that I could draw that would hit this place twice, that would hit this parabola in two different places. It only hits it in one place. And that's an indication that when I plug in, for this one, for example, when I plug in the number 2, when I plug 2 into this function, the output is 3. So I have the point 2, 3. I don't have repeated values. I don't have another point, for example, that would be 2, -5, right? That doesn't exist. That would be a point that existed here, right? 2, -5, and then I would have a vertical line that hits twice. But for the graph that exists for this function, every single possible vertical line that I draw is only going to hit this graph in one place, okay? Now, when you're doing a Math Excel assignment on this, the questions look like this. Determine whether the following equation defines y as a function of x. And really, all this is saying is this a function? All right. And there's only one test we need to do for that, and that is the vertical line test. I abbreviate it with the VLT, right? This is the only test we need to do when they're asking me this question. And we might as well use the technology that exists to help us do this, right? So what we do is we can use Desmos. Okay, I'm going to turn these graphs off. This is for a different time. So I can take this graph and I can plug in, what was it, x squared plus y squared equals 25. I can type that in exactly how it shows up. Right? This is the graph of this equation. What do you notice about it? Okay, it's a circle, right? Because it's a circle, if I want to draw a vertical line in here, right, then that vertical line is going to hit in two places, right? If I draw a vertical line right through here, I would be hitting this graph down here and here at the same time, right? So if you just look at this grid line, when x is -2, when x is -2, I'm hitting this graph here and I'm hitting this graph here. So on this vertical line, I hit the graph in two spaces. So for this, we would say, determine, no, it is not. No, because it fails the vertical line test.